Okay, for example 4 is easy, but like still the format of writing answers. So decide whether the following points are in the region defined by 2x minus 3y greater than 8. So you substitute x, substitute y, you want to see a value smaller or greater than 8. So what you can do is sub x equals to 5, y equals to 0 into left hand side. So left hand side equals to 2x minus 3y. So it's 2 times 5 minus 3 times 0. That equals to 10. Okay, that equals to 10. So right hand side equals to 0. Not 0, 8. Left hand side greater than right hand side, which satisfies the inequality sign, right? So 5, 0 is in the region, not on the line, is in the region. Okay. So still we talk about left hand side and right hand side. We're not going to substitute x, y into the equation directly or inequality directly. So for the next one, I'll say sub 5 x equals to 5 over 2, y equals to negative 1. So left hand side will equals to 5 over 2 times 2 minus 3 times minus 1. That equals to 5 plus 3, that equals to 8. Okay, left hand side equivalent to right hand side. I don't want equal, I want them greater. Okay, I want that greater. You just give me a point equal, which is not satisfied. So 5 over 2 comma negative 1 isn't in the region. Okay, but if the sign is greater equals to, then the point will be on the line. Okay, if the sign is greater equals to, then this point will be in the region. But because the street greater, then it's not in the region. Okay, next one. 0 and negative 1. So I will sub x equals to 0, y equals to negative 1. So left hand side will equals to 2 times 0 minus 3 times negative 1. And left hand side will be 3. Left hand side will be smaller than right hand side. So 0, negative 1 is not in the region. Okay, last one. Last one is 2 and negative 5. So sub x equals to 2, y equals to negative 5. Left hand side will equals to 2 times 2 minus 3 times negative 5. That's 4 plus 15. That equals to 19. Left hand side greater than right hand side. So 2 negative 5 is in the region. Okay, example 5. Example 5 is like asking in the other way. Like how it asks you is determine the original inequalities that should give you the following region of intersections. Okay, so I want you to write the original inequalities. Can you see this thing? Do you think it's bound by 2 lines or bound by 3 lines? Where's the third one? X-axis. Okay, so it's this x-axis. So remember there's still 1 line here. Okay, so that's a solid line because it hasn't shown you dashed line, so must be a solid line. Okay, now let's go to see this one by one. So the first one must be, that is y equals to 0. Let's find those 3 lines first. That's y equals to 0. Okay, see this dashed line. See this dashed line. For this dashed line, let's find the equation for that. So what's the equation for this? Okay, we have a 0.16 pass through that point, and we have a negative 20 pass through that point. So we want to find equations for that line. So remember how we find equation for those lines. Do we know the gradient? We don't know the gradient. So we need to find the gradient. So how we can find the gradient is y2 minus y1, so 0 minus 6 over x2 minus x1, negative 2 minus 1. Okay, so m will equals to negative 6 over negative 3, and m will be 2. M will be 2. So the gradient of this line is 2. Okay, gradient of this line is 2. If gradient of this line is 2, do we know the y-intercept? We don't know the y-intercept. So if we don't know the y-intercept, which equation we should use? Y minus y1 equals to m times x minus x1. So I can choose any point to be x1, y1. This one looks easy. I will use that one to be x1, y1. So y minus y1, which is 0, equals to m x minus x1, which is minus negative 2. So y will equals to 2x plus 2, and y equals to 2x plus 4. Yeah, 2x plus 4. So this line is y equals to 2x plus 4. Okay. And for the solid line. Okay, for the solid line. So for the solid line, it passed through the point 0.07 and it's also passed through the point 1.6. Okay, question is, do I know the gradient? By 2 points, I don't know the gradient yet, so I need to work out the gradient. So the gradient will equals to, okay, 7 minus 6 over 0 minus 1. y2 minus y1 over x2 minus x1. M equals to negative 1. 1 over negative 1, m is negative 1. Do I know the y-intercept for this one? Yes, right? So we can directly write y equals to mx plus c, which is minus x plus 7. That is the solid line. Y equals to minus x plus 7. Okay, now I have worked out the 3 lines. So that should be 3 set of inequalities. So first one is y and the 0 with the relationship y with the relationship of 0. The second one will be y of the relationship of 2x plus 4. And the last one will be y and minus x plus 7. So the thing I need to look at is, where is this shading area? Okay, below or above? Let's think about y equals to 0. Is that shade region above 0 or below 0? Above. So if it's above, I need to have greater equals to. Okay, otherwise you cannot have regions like that. Okay, it must be above. The region is above that line, so y should be greater or equals to that. It's a solid line, so I have greater or equals to. Okay, for next one, 2x plus 4. This region is below this linear or above this linear? below, yeah, everyone can see that's below, okay, below the region. So that's a dashed line, so y needs to be smaller than this. Okay, the last one is minus x plus 7. The region is below or above? Still below, okay, still below. Lines here, the region is under, okay, it's under, so it's still below region. So that should be smaller equals to, that's a solid line, okay, smaller equals to. So which means it's under those two lines and above y equals to 0, and that gives you this triangle area. So going backwards, the first thing is by using all the points, work out all the linear equations, and just think about your shading area, your result area actually above or below the line. If it's above, you write y greater than. If it's below, you write y smaller. Look at the dash or solid line, you have smaller equals to or smaller, greater equals to or greater. Okay, so that's the work backwards. Okay, that work backwards. Any question about this? No.